first off, yeah, thank you, Samantha, for the little introduction there. Thank you for sponsoring and everything else. Thank you for PHP Architect, everything that they do. My name is Andrew Cassell. I'm a PHP application designer and developer. I do it all for a nonprofit called the Marine Spill Response Corporation. And one second, hold on, my slides got this. I don't know why I'm not in here. Just a second, sorry. Oh, my screen's here. There we go. All right, sorry about that. All right, as I was saying, I do basically full stack development for this nonprofit Marine Spill Response Corporation. I've been there for about 9 years. I work on a small team with 2 other very talented developers. We are the largest dedicated oil spill and emergency response organization in the United States, strategically placed all around the United States with all kinds of boats and airplanes and equipment ready to respond for an oil spill. And what we do there is we build several internal custom applications for the organization to help maintain that equipment, track it, and we also do their public website. So before I get into the talk, I'd first like to thank everyone that made this talk possible. These are the primary developers for both Composer and Satis. Jordi Borgiano, Niels Houderman, Igor Wheeler is his last name, and a few other people who have contributed to both Composer and Satis. And then in this talk, I'm going to be using a few examples from Dependencies, lead packages, and doctrine. Okay, so I gave this talk last year at PHP Tech, and telling you that because some of the examples actually use material from their website at the conference. So you're not confused when you see that. I told Samantha like a week ago that I could do this. I didn't have time to come up with better examples, so you got to deal with these shitty ones. All right. So as software developers, we've all been doing it as long as you can see from this picture. We learned a long time ago to stand on the giants, or stand on the shoulders of giants, and rely and reuse code that we find on the internet or from our friends. And maybe it's because we're so intelligent, or maybe it's because we're so lazy. But anytime we have a problem, we never want to try to solve it ourselves. We want to go find code and use that. And do I need my part of the application? Do I need it to send emails? Well, I'm going to go online and look how do you send emails and find some code to do that. What I'm talking about here, that other code, that's a dependency. And what I'm going to talk about here with Composer is how to manage those dependencies and how to make it easier to do so. So what is a dependency? A dependency is a software library or package that is required for an application. So if you're building a Drupal website, then Drupal is a dependency for your application. If you're using PHP Mailer to send emails, then PHP Mailer is a dependency of your application. However, your dependencies might have further dependencies. Now you can manually download those libraries and unzip them and drop them into your PHP application. Put them in your project folder somewhere and try to keep it all working together. But I think you'll see as we go through the examples here in Composer, you find that it's much easier. Now, what's a presentation without a quote from Steve Jobs? Steve Jobs famously said, quote, bastardized from a T.S. Eliot quote, who was misattributed to Picasso, good artists copy, great artists steal. Now, I think if Steve Ballmer was here, he would say good developers copy, but great developers use Composer. So what is Composer? What does it do for you? Well, it does 4 things primarily as a dependency manager. 1, it's going to download all those dependencies for you and put them inside of your project. It's going to download the dependencies of those other dependencies. So if you're using Laravel and Laravel uses other components, it's going to download the dependencies that Laravel needs. Or if you're using Symfony components, they're also going to download the other Symfony components that are necessary for using them. It's going to verify the compatibility between all of those dependencies. So when you see online open source packages, you'll see they have in their Composer JSON file, they have a description of what dependencies they need, and it's all based on versions. So one version, it'll say we require version 2 of this other dependency. You'll see how it verifies it compatibility later. And the fourth thing it does, it creates an autoloader for all of those dependencies. Now, if you've been doing working with dependencies long enough and used other tools like Pair, I think you'll find that there's a huge difference. Because between using Pair, trying to run your own dependencies, without that compatibility check, what you end up in is dependency hell. And dependency hell sucks because your application breaks and you have no idea how to fix it. Or you end up having to refactor the entire thing to use a completely new piece of software to do what you're trying to do. Now, I would say that PHP development has largely changed in the past couple of years. The language and the ecosystem around PHP are modernizing. We're in the middle of a PHP renaissance, and the work done here at Composer by Neil Zeiderman and Joy DiBiagio, to both Composer and Packagist, which is the directory for Composer, it's made it easier to reuse code unbelievably different than it was before. And the work of the PHP Fig, which is the framework interop group, has made it so all of these packages can work well together with auto-loading and everything. So all of these different packages like Symfony, Amazon Web Services, PHP Unit, Laravel, Doctrine, they all work together really well. All using Composer to bring them together. So how do you install Composer? Well, it's really easy. Go to getcomposer.org, that's their website, and they have instructions there. It's as simple as doing something horribly insecure in your computer and curling this website and typing it to PHP. Otherwise, you can download it and verify the MD5 like any sane person would do. But I would recommend installing it globally. So put it somewhere if you're using on your Mac, install it globally to the system, and keep it up to date. Every 30 or 60 days, we'll usually tell you Composer's out of date, you need to update it. There's really no reason to not have it updated. On Windows, it's really easy to install, but now you have more problems. So how do you add a dependency to your project once you have it installed? So just path into the folder in your project, type in Composer, require, vendor name, package. So if we want to install the Amazon AWS SDK to use all the wonderful Amazon Web Services, this is what we would type. When we do that in the terminal, we'll just look at the output here. It's going to say, okay, I found version 2.8 of that in the Packagist directory, and Composer JSON has been created. It's also going to tell us what dependencies that it installed, which in this case were dependencies of the AWS SDK. So it installed all these 3 packages, and probably some more. I probably cut it off. But so when it's done with its process there, it will have created those 2 folders, Composer JSON, Composer lock, and then a vendor folder. So the first thing we're going to talk about is the Composer JSON file, which is basically a JSON formatted file of the configuration of Composer in that project. It's not a global configuration. It's specific to that project that you're working on. So this is the file that would have created there when we type Composer require AWS SDK. And we can see there it's a little bit cryptic maybe with the version there with the caret, but it's using version 2.8. Now you notice it didn't say anything about those other dependencies that I installed in the Composer JSON. Those have all been taken care of, and they're in the background in that other Composer log file. If you've been using Composer long enough, you probably would have seen it as tilde 2.8. That's just another syntax. We'll get into the syntax of versions in Composer. You can also specify the version number, 2.82, and be very specific. And say that I want that version of the package. Now, when you start getting into multiple versions of packages, you can, or sorry, multiple packages, you just basically list them just like you would a, I guess it's a hash map or something. Whatever they call this thing. Basically, it's a list. You can either edit this file by hand and then use Composer to update it from that, or you can do Composer require the other package name, and it'll automatically add this to the list. So there's different ways you can use Composer. Now, to really understand how to use Composer and how to maintain your code and continue to use it, you really have to have a good handle on semantic versioning. So take a little sidebar here and have a little discussion on semantic versioning so we get everybody involved, everybody on the same page. Because there's a lot of software out there that's done and released that's not semantically versioned. So when I talk about semantic versioning, I'm talking about the three numbering system, the three numbers here you see with the decimal places between them. And these are each broken down into a section. So you have patch number, the minor version number, and the major version number. Now, the patch version is when you make backwards compatible bug fixes in your code. The minor version, the middle one, is when you add functionality in a backwards compatible manner. The major version is when you make incompatible API changes, basically, where you make a huge update that everybody else that's consuming that code needs to update for. They need to do something to their code. You also see a 0 dot something, and that usually refers to that this software is in beta and it's not exactly ready for production at this point. Use at your own risk, I would say. So, and we're going to get into writing your own packages later, so this is also a good thing to understand too, because, okay, let's say you've written your piece of software, your open source package, or your closed source private package, and you've numbered it 1.00. Now, what happens if you want to make a backwards compatible bug fix? You increment the patch version to 1.01, commit it, tag it, and push it up to the repository. Now, what would happen if you're going to make 15 more backwards compatible bug fixes? Or, basically. That's going to go to 1, 0, 16. So it's not based on a decimal, 10 decimal system. That you can literally have any number of versions inside of each one of those major, minor, or patch. Now, how about a new feature that doesn't break existing code? So if somebody's using your package or your little piece of software, say it's an email package, if you're going to add new features to that email package or that caching library or something like that, you can do that, and as long as it's not going to break their code, just make it 1.1.0. So we've incremented the minor version saying that this is a fully compatible with 1.0.16. There's just been internal changes that won't break existing code or new features that the people can use, but there should be nothing that the developer has to do consuming the difference between 1.0.16 and 1.1.0. Now, what if we want to make a change that's incompatible with the code that people have been using this package previously? So everybody's got 1.1.0 in their Composer JSON. They've been using it for a while. We're going to make a change that's going to make them change. We're going to move that to version 2.0. And that's probably the biggest lesson here of semantic versioning is don't be afraid to change the major version number. Now, unless you're the one working on Drupal or Laravel or Symfony or something like that, where you have a lot of people using the code, and you want to bring a lot of features all together at once. So you want to make a big feature change to Symfony 3 or Zen 2 or something like that. You want to bring everybody on board all at the same time. That's when that's when maybe you'll wait to make a major version change. But my advice for just like internal packages or things that you're doing on your own, don't be afraid to change this major version number, because that's what will signal to you and the other people on your team that we need to look at this code and see what's changed. Because I know personally, my code is never well documented. Stuff, especially that I'm writing, internally for our organization. And it usually takes looking at the actual Git commits or something, or the messages, see what has changed between version 2 and 1, and what do we have to change in order to make it work with version 2. So now that we have kind of a handle on semantic versioning, let me show you a few little ways you can basically let Composer handle those minor and patch updates that you shouldn't have to worry about. As long as you trust the package to not break your functionality, you shouldn't have to worry about updating that quite as much. Without, I would still, have your code tested, have a test harness around it, but it should be safe to do these updates. So, kind of the way that Composer had been doing it for the past few years is using the tilde. And what that means is this will go from version 2.82 to 2.89999. Basically any other version of this. If you just did 2.8 tilde, it'll go up to version 2.999. Basically, it goes one level higher, basically, always. So if you have a tilde 2.82, it goes to 2.89999 repeating. If you had just tilde 2.8, it would go to 2.99999. It wouldn't go to version 3. Now, again, I said you should trust code going between version 2.8 and 2.9 as long as you trust the developers behind that package to not break existing functionality. Now, Composer gives a better way. It's using the caret symbol here. So if you say, I'm going to require 2.82 because maybe there's a bug fix in 2.82 that you absolutely want to make sure that was in there. Using the caret will let it go all the way up to version 3, but not include version 3. So you know that you can run Composer update and probably not break your existing application the way that it's using the dependencies. So some people like to do it this way with the carets and the full version. A lot of my internal stuff and everything, we just typically do caret and then major and minor versions. There's just not really any huge benefit to having the bug fix patch version listed there. It's just easier to read. You'll see this occasionally. People use star. I'm not sure why the quotes are messed up in that, but should you use star? No, should not use star. Because if they go from version 2.0 to 3.0.0, that means they've made a backwards compatibility change, or break backwards compatibility. Your code may not work between version 2 to version 3, and you may have some bugs that will occur when that happens. You'll also see one.star. That's okay. That'll use everything in the version 1 system, but they recommend you don't do that. It's just uncivilized. Another thing you might see is dev master. Should you use dev master? No, you shouldn't. Because what that does is that it actually clones the repository instead of downloading a distributed version of the code. So you end up essentially with a Git submodule or a subversion. I don't even know what would happen. Zombies, I have no idea. So, I mean, you can hear, here's one of the guys working on Guzzle, and he says, I'm working on a new version of Guzzle. And he was getting support requests because people were using dev master, and he was committing to the master without tagging the version yet. And it wasn't essentially ready for production. But people's code in deployments were failing because of that. So the other file that I mentioned that was generated is the composer lock. And what that does is that actually locks your dependencies that are in your vendor folder, which I'll mention here in a minute, to a very specific version. So every time you can run a function on Composer called composer install, it will look at a composer lock file and install the specific version of that application. So we mentioned before using the tilde. So if 2.82 is out, and then they upgrade to 2.89 setting. Now, if I run composer install with 2.82 installed, and then I run it again 3 months later without doing what's called a composer update, it'll still install 2.82. It won't go and fetch the latest version. What that does is that guarantees that the code that you expected to be there when you ran composer update or installed the library at that moment will always be the same code that's installed again and again and again. So for that reason, all you have to check in is your composer JSON and your composer lock. you don't have to check in the vendor folder that's created where all the code lives. So that's the difference between composer update and composer install. So composer install will look at that composer lock file. If it doesn't exist, it'll look at composer JSON and build it. But that's kind of a minor detail. Usually, the first time you use composer, you'll get both files. So composer install, that's going to look at the composer lock file. Composer update is what then you'll use to update the lock file and update the dependencies that are in your project. So if you're using version 2.82 of Amazon's SDK, 2.83 comes out, you can run composer update, it'll pull down version 2.83 and update the lock file. Then you would commit both of those files in your repository. I wouldn't recommend running just composer update. What you can do is a little tip here is always do composer update and then specify the vendor and package that you're going to be updating. And the reason for this is that way it doesn't update everything all at once. So if you do have a problem, you can kind of narrow it down knowing that you didn't have 15 packages installed and where's the bug here. It's just safer. Now, if you're going to deploy, now we can get into a whole 4-hour-long discussion tonight at the bar about how you should do deployments. But if you're going to use Composer for deployments, which a lot of people do, and it's perfectly fine, you want to use Composer install, never use Composer update. Because, again, when I said Composer install, it's going to pull the versions of the software out of the Composer lock file, which will give you the specific version of that package. And you know that it works with the same one that you're using on your development machine. So let's look at a few other parts of the Composer JSON here. This is an open source project called OpenCFP. It's a call for papers application, which I'm sure if you're going to submit to conferences, you've probably used this. So there's a name and a license, which doesn't so much matter for your own code, but if you're going to write an open source project, you want to use that. You can see how many dependencies that this application uses, quite a few. Next important section here is auto-loading, and we'll get into that, how to use that, and how that's going to simplify actually using these dependencies in your code. And then the auto-load dev, we'll get into that. That's an option when you do Composer install or Composer update, I think, with Composer update, not sure, where you can specify dev dependencies. So right here where they have required dev, you'll see PHP unit, mockery, things that you're going to use in development only, things that are dependencies for your development process, like writing tests, doing mocking for writing tests, the PHP fixing, doing code cleanup, things like that. Stuff you don't need to deploy to your production machine. So you can save some bandwidth on your production servers. If you're going to use Composer to do your deployments, it'll speed up your deployment a little bit if you move those dependencies out of the require statement and put them in the require dev. So one of the other features that I kind of mentioned there at the end of the features part was the dependency resolution, essentially the checking to make sure that the versions of things work together. So if you were to do Composer require pimple2, which is basically a dependency injection container service locator kind of thing, and then do Composer require Silex, it's going to tell you that version 2 of Pimple and it's trying to install version 1.3 of Silex. Those two things are incompatible. So it's going to warn you and keep you out of dependency hell before you even get to that state. So, I mean, I know I've done it in the past, years ago, just downloading packages or software off of PHP classes or Stack Overflow or something, and you're like, this doesn't work with the other version I'm using. This will tell you before you get into that problem. So maybe this far you've been wondering, Daddy, where do packages come from? They don't come from the store, no. They come kind of through Packagist. Packagist is the directory, essentially. It's not actually where you're going to download the code from. The code's going to come from wherever it's stored, usually on GitHub. So Packagist is where you're going to go to look for packages, and we'll go through how to do that in the example here in a minute. So to talk about the vendor folder a little bit, this is where the code is going to lie. So if you're using SwiftMailer to send emails, the SwiftMailer code is all going to be in there in the vendor folder. You're going to want to add the vendor folder to your gitignore file because you don't need to check it in. That composer lock file is going to make sure that everything that's in the vendor folder is always the same. Every time you run composer install, it'll always be exactly the same as it was the last time. Unless GitHub crashes, then it won't work. All right, autoloading. Let's talk about autoloading. Autoloading is awesome at shotguns and PHP. But in order to do autoloading, you need to understand namespacing. Now, namespacing in PHP is a way of organizing code so that the class structure and components that go together are organized in a fashion that makes sense. So here we're talking about a Symfony component, the request object, which is an HTTP request, for example here. And the class request is part of the HTTP foundation component inside of Symfony. So they've namespaced that. Now, the advantage of using namespacing is that somebody else can have a class called request. It doesn't. It can. They can all live in parallel, but they're organized in a way that the namespacing takes care of that. And I'd recommend if this doesn't make sense to you, find more tutorials on it because I'm not going to cover it, in depth here. But basically, having that namespace lets you add the class like this with a fully qualified name, or you can use what's called the use command and shorten that or alias it. You can say use Symfony request as a piece of crap and say new piece of crap. Doesn't matter. So this autoload file that I was talking about that's generated and put in your vendor folder, that's what you're going to include in your project once you've done compose or install. You somehow need to get that in your bootstrap file or in somewhere, how you're doing a config file or something. That needs to be one of the first things that's loaded up in the PHP script that runs. There's something that's put in there usually. It's a vendor bin folder. That's where everybody's putting basically symlinks or aliases to the actual code that'll run. So you can just go into your folder, and then when you need a star here if you're on Linux, type */vendor bin PHP unit, and that'll run PHP unit. So you don't need to have PHP nav or anything in front of it to run. So let's go through an example here of using Composer, how to have your project use packages from the Packagist directory, and go through a complete example here. So we're going to use some code from the League of Extraordinary Packages, which is a great example of some packages that are out there that you can get and use in your app. If you need CSV downloading or exporting, there's a CSV package. We use that a lot. There's a routing package that you can use, URL manipulation. They have the Fly system. Fly system is great if you're using AWS SDK. Others like file abstractions, it basically makes all that disappear from you. You have no idea the difference between that, in a file that's local. We're using their dependency injection container where we're using a lot of their stuff. That's all at phpleague.com. So for this example, let's scrape the content that's on the PHP Tech 2015 website. I mentioned I made this example for that, so it probably made more sense then. But this is a good example. So how would we have done this before we had Composer? We probably would have wrote some of the stuff. We would have used probably the curl library for PHP, the curl extension. And that would have been probably awful. Probably would have used some sort of XML parsing to try to pull the HTML out of it. Of course, XML is horrible too. And then as part of the requirements for this project, let's say we're going to scrape that data off the website or output it to YAML. I have no idea how you would have outputted to YAML before having Composer and Symfony components available to just pull in your project. You don't even have to use the entire Symfony library. You can just say, oh, I want Symfony YAML. So you get parsing and outputting in YAML. Basically no effort. So let's go through a little example of how to do this and how to do PHP the new way, essentially. So go to Packagist, type in scraper, and then you'll see on the far right there's two little kind of sorting things. Sort by downloads or stars. Now both of those can be gamed, but usually it gives you a good idea of who it is. You can go to the GitHub page, find out more about it. But basically you copy that line, go to your root path of your project, paste that sucker in. It's going to put that package in your code. How about a YAML parser, or YAML output actually in this case? Just type in YAML. You don't have to go to Stack Overflow and say, oh, what do I want to use for YAML in PHP? You got all the stats right there to see what people are using. Copy paste that, drop it in your terminal. What happens when you're done with that? It's going to build a composer JSON for you. You'll have those two libraries in the composer JSON. Composer lock, well, that's going to be full of other stuff because that scraper, the Goop, however you pronounce that, that's using Guzzle. The YAML one using a few other Symfony things too as well. So yeah, let's zoom that in a little bit so you can see it better. So how do we write this scraper script? Well, first thing we got to do is require our vendor autoloader. That's going to make, so the next line, you can just say new client, using that fully qualified name. Now you can use that. There's nothing else to do. No other require statements to put at the top of your script. Nothing. It just works. And then you can use the crawler from that. Now, this is the full version of the script. Basically, it just does exactly what was at the top there. It does a crazy bit of array manipulation. And at the very way bottom, down the bottom, it exports the YAML. And you get all the data right out of it just from scraping their website. So that was like a 10-minute, a problem that may have taken quite a bit of long time before, but now with Composer, deal with it. 10 minutes. As it's been said, once you go Composer, you'll never go back. Thanks, PHP Dad. All right, does anybody have any questions about Composer so far? How to use Composer? Go for it.
Question. Having a dev server and a production server,
yeah,
and you want the dev server to be updating with, say the master branch or the head of your developer. Do you have any thoughts on how to manage that between two different servers with the same Composer JSON file?
You're talking about the dependencies for that project? You're looking. I don't do that. I would typically look at updating. That's why I don't run Composer update like globally. So the Composer lock file is going to hold everything to a version, a very specific version inside of the vendor folder. So even going from your dev machine to this test server to production, everything stays exactly the same.
So these are internal packages. So things that we're developing.
So it would be the same way when you go, if you're using Satis or these that I'm going to show you here in a few minutes. We're going to transition here to a section entirely based on a code that you're going to write and host internally on your organization. That wouldn't be a problem. I never would push something to test or production without first updating that little package on my machine, making sure all the tests are passed. Or, lying, because there's not always tests. But let's be honest here. But I would test it and make sure it works.
So I think I understood it right. So your problem is that let's say your QA service to apply step branches and program branches and then production to master branches. Right. So we will face the same problem. So the way we handle it is you can actually create multiple composer files with environments. Let's say composer.qA.json, and then when you run composer commands such as install or update, you can put it in the environment-specific composer file.
Okay, so you're talking about deploying something on multiple different environments too, probably. That's right. Okay, so you can actually do a few things there too. On your deployment server, you can have your Composer JSON, and then you can make changes to it on the other server using the command line tools of Composer. Like, it's probably what I would do if you're using some sort of like vagrant script or something like that to set up the different versions. Just have it do those command line changes maybe even too. If it's minor, you do those command line changes and then do Composer install. So essentially modify that checked out version of Composer JSON after the fact. That's another option too. If you only have a few changes between them. Yeah. Terrible idea. Any other questions? No. Okay. So let's talk about code that's mine or yours. I've shown you how to get open source packages from the internet using Packagist. Now let's turn this internal and look at private code. So right off the bat, Composer loves Git, and Composer loves Subversion. So if all you have is a little tiny simple package, and then we're just looking at the normal Composer JSON that we had before with the require statement, you can add a repository section and list your repository, whether it be Git, Subversion, or maybe Material, I think there's a few other ones, or you can point right to a tarball file, basically, and this will download the code. The only limitation there is if this secret sauce project has other dependencies, Composer is not going to get those for you. So you would have to list all of your dependencies in the Composer JSON for that additional, for secret sauce there. However, I'm going to show you if you use Satis, that'll actually download the dependencies for that other dependency as well. So yeah, if your code has dependencies, let's use Satis. There's also a paid-for software. It's open source. You have to have a license. This is written by Joy DiBuogiano. He's got the guy that was one of the lead developer on Composer, and the open source project that I'm going to show you here in a minute, Satis. This is his commercial alternative to it. It's a little bit easier to use. They offer professional support. So if you got the money and more money than time, this might be a good option. Definitely worth looking to. Small team of 3 to 5, you're talking $25 to $30 a month. It's probably average. There's also a in beta version. This other Dave, I can't remember his last name. Somebody else will probably remember for you, but repobox.io. They'll host basically an upgraded version of Satis for you. But if you want to do it yourself and use the free open source alternative, it's under the Composer project on GitHub. It's called Satis. And it is a package repository server for you. It's really easy to configure and set up. Just assuming you have a good PHP server configuration already. I think it requires PHP 5.3. So all you have to do is path to the directory of where you want it to go. In this case, I'm like under serve www satis, and you just type Composer create project and the name of the package Composer Satis, and we're going to actually clone the repository here instead of getting the version, the distribution version. And that's going to install the source for Satis and all the dependencies required. So I think you'll see this from more and more open source projects where you'll be able to install right from Composer. That's it. It downloaded the project. So then all we need to do is run php bin Satis. Remember that the bin folder from the vendor folder there. Build, and then you pass through a configuration file and the output directory. And the configuration file, I would generally call it satis.json. This is an example of one here. So the home page is where you're going to be hosting this. This would be on your package server, name packages or some other creative name you come up with. And then you're going to list the repositories that you want to actually have your code in. That can be Git, Subversion, or actually different examples here. You can use different syntaxes like git at, just like we did before. And if you want to have every version of those packages that you have, you just do require all. So what did we do for Composer and Satis? We copy pasted code up between projects. We would just we've been using source control for a long time, but we would go to the other project, copy paste the code out, and drop it in. At one point, we created a separate library repository where we just dumped everything in it. And then, as you can imagine, like, oh, let's go update this one app, but the other one's going to, kind of fall behind. You update that lib repository, and both apps are trying to use it. You get into this dependency hell of one thing being updated, the other one not. We also tried Git submodules, which were absolutely confusing and sucked. I mean, just they made releases. We never knew it was going to be installed. It was scary. All right, so let's go through another example here. We're going to use kind of the same thing, scraping the PHP Tech website. But what we're going to build is just a little tiny display of this that is much more condensed than the one that they had. If I wanted to use this on my phone so I could look up, see what the other person's talking about, I didn't need all the description. So what I did was I took that scraper.php and I dropped it inside of a private repository on GitHub. And the actual class is in here inside of the source folder. In my Composer JSON, I've specified, here's the scraper file. It's basically the same as it was before. And then inside of the Composer JSON file here, I'm specifying the requirement of the XML scraper here, which is the group here, which has a crawler and everything built in. So this this package is designed to scrape their website and pull data out of it in an array. Yeah, so right here we've got the version that we're requiring. We set up a autoloader for this. So if we use the package, the original one we were talking about, the scraper, we're going to specify our namespace as Secret Corporation PHP Tech. And anything that's in the source folder will basically path to this namespace. And this is using a PS4 autoloader. Go on the PHP Figs website if you want to learn about PSR 0 versus PSR 4. But PSR 4 is the current standard for autoloaders. It's not very hard to change, just a little bit of a tweak in the syntax here. So our Satis server is sitting at packageserver.example.com. So in the config of the Satis server, we're going to set our home page to that. That's just for the URLs, basically, so the URLs and downloads work. You have to match that with the where you're actually hosting it. And then these are the 3 repositories that we're going to use in this demonstration. So we've got the scraper. I've also built a simple cache library and then an S3 file wrapper. We specified require all. That's going to download every version that we've tagged in the of these releases of these code libraries, and then archive dist. That's going to, when it downloads the version of this code, it's going to automatically create a tarball and zip that up, so it'll be faster. So once we have that JSON file set up, we run our command. We're going to be building using the Satis JSON that we just had in the previous slide to a web folder. And just using Apache or Nginx or any of those other, you can just host this file. And basically, this is your package server. This is like a mini version of that Packagist website. It gives you a really kind of crappy way to filter your packages here. I think we're right around 30, I think, or something like that, packages. Don't quote me on that, I'm not sure, but it's not that useful. You don't really have to use this interface this much. What you're more concerned about is the files that have been generated in the background. So what it's done is it's generated the same files that Packagist.work uses to build the directory of every version. You can kind of see here, you've got all the versions listed here. You can click these and actually download the source for that package. But what's really important is using it in Composer. So for this demonstration, we're going to use a mix of both closed source stuff, and we're also going to use a few open source packages. This is Plates. It's one of the League of Extraordinary Packages package. So let's add that to our, now we're talking about a new project that we're going to build using that example I was going through before. So we're going to require League Plates, and then we're going to require the PHP text scraper that I was talking about earlier. And you have to point it saying that the type of repository is Composer now, not Git or not a VCS. And you're going to point it at your package server, the URL for your package server. You see right here, I've specified secret company example, PHP scraper 1.00. And if you look previously on this previous slide, you can see, well, maybe off the bottom here, but 1.100 is available. So it's going to download that and drop it in my vendor folder. If I use the vendor autoloader, I can just use the Secret Corporation PHP text scraper just like that. All your dependencies work as well. They're also in the autoloader. It's downloaded all those dependencies for that package. They're there. You can use it too, along with your open source stuff, all in the same thing, basically. And this is all the code that's needed now to do this display. Now, every time it does that, it goes curls the website, pulls all that stuff down, parses the XML, and displays it. It takes maybe 5 or 6 seconds. So let's speed this up a little bit. Let's add some caching and a few other little nifty things here. So what we're going to do is kind of a developer workflow here. We're going to say, let's update the PHP scraper and make it dependent on a caching library. Now, this is probably tightly coupling things when you should be more loosely coupling. But it's also a common example when you just want to take the PHP tech scraper from 1.00 to 2.00. But you don't want to go and develop that in a silo. Maybe you're kind of still working on it in the app that you're building. So you want to make some changes to the scraper. You're not really sure what you want to do yet. you can actually switch this to dev master, run your composer update, and it's going to clone the repository, the original source of this, from your private GitHub repository, or wherever it is, your private Git repository, and clone it instead of pulling the distribution. So you can see here, it's going to remove the downloaded version 102 and install the dev master to the specific commit that it was talking about. So now, if you go into the actual vendor folder, secret company example, PHP text scraper, and you run a git status, you'll see we're pointing to another Git repository. So it's actually kind of like a Git submodule at this point. We're working within that. And the autoloading and everything continues to work. If you go back to your previous, you go back to the page and hit refresh, it keeps working. It doesn't matter if it's in another repository or it's a downloaded package. So now you can make your changes. You can pass down your IDE or whatever you're using, and you can make your changes here. And whatever, like let's say we're going to add cache to it, I think, and so we've added a cache dependency. It's hard to see the example here, but now we've injected some dependencies for a cache. We're setting the cache, and when we get the speakers, we just dump it to a cache, and it doesn't exist basically. So it's a very simple change here that we're making. We're just dropping a dependency in for cache. Now the scraper has caching ability. So that was all done in the Git submodule, which is its own Git project. You would now basically, this is kind of easy. You now use, go back to your command line, path into that vendor secret company, I think it was, scraper project, type git add, git commit, just like you would for the package. Now you could be developing this package in an entirely different folder in your computer, but you wouldn't get the advantage of also developing it alongside of your main application. So if your package has full test harness, it's well defined, maybe you don't need to do this. But I like this method because you can actually make sure it's going to work in your application before committing the next version of the package. So just git commit, push it up, maybe push to master, and then tag it. We're going to go to version 2 here, so we just add the tag. Maybe you want to make a better message than that. Push the tag up. Now take your composer JSON, switch it from dev master to 2.0. Run composer update. It's going to pull that down, and you're going to want to add the other dependency there for the cache, which we've used another secret corporation private package cache. Now that's just basically document cache that's been wrapped. But again, you can specify dependencies from anywhere, from any of your internal private packages, and they all work with the autoloader, and you can just use them right away, just like this. Now, if you were to load this page, it loads almost instantaneously. So just to go through that kind of workflow, once again, you're going to take your package that you have, switch it to dev master. It'll then do a composer update. It's going to pull down the clone the repository. Make your changes that you want to in that package. You can also run your tests for that package inside of that folder. Make sure that they pass. Tag a new version, say it's version 2.0. Push the changes and tags. One little step in here, you want to do a Satis rebuild. That's going to update that directory, so that way your app knows the full version 2. And then do a composer update, and it's going to basically remove that cloned repository version and use the distributed source. That way, when it goes to production or test server, it uses the new version and downloads it. I think this workflow has it works really well for us, and I tend to enjoy it. I feel like it gives us package superpowers. We are, it just is a great system, and Satis is a bit clunky to install, maybe a little bit. It's not that hard to configure and stuff like that. You can use those other bits of software, the torrent proxy that I mentioned. A little bit easier to set up, but I don't think Satis is that hard. Some improvements you're going to want to make to your Satis system if you're using Satis. You're going to want to cron the rebuild, and this will I'll get into more in a minute here, why that's important. You're going to use the git hook. So if you're updating your packages, that way they automatically force the Satis to rebuild. Or if you're using GitHub, use a GitHub webhook. An example that Jerome Tomara, I can't pronounce his last name, but he just had this as his Git webhook. I think this is just beautifully simple and easy. and then he has it croned automatically every minute if that file exists to rebuild Satis. It's just a really cheap, simple, easy way to have a webhook basically point GitHub at this file wherever you host it, and it just works. Another cool little feature of Satis is that you can actually mirror GitHub. So if you're using open source packages, and it might be a little bit difficult to see here because I make the font size small, but if you're specifying that you're using both Packagist and your own internal repositories, you can specify the actual open source packages here, put a star, or if you're only using later than version 3, put greater than version 3 or something like that here, and that will download those packages off of GitHub and mirror them on this server. Which, if you're using Composer to do your deployments, don't forget this part right here, archive gist. If you use Composer to do your deployments, when your server goes to do its install, it doesn't have to go all the way up to GitHub and maybe hit GitHub rate limiting or something like that. It will pull it off the local Satis server. So you're going to be hosting copies of like the Amazon SDK or something like that on your Satis server, which makes deploying a lot faster too. So there's a lot of advantages to doing this. Tux Plus has a great example on their website. There's some links here, but they forget, they haven't updated it, this part right here. You want to use direct distribution. That'll use the tarballs. Makes it a little bit faster. Now, securing your Satis server, there's just a couple things you want to keep in mind. There's no security built into Satis. Some of the other, like Tor proxy and a few other ones have a little bit of security built in. You're never going to want to put your credentials in the code because on that Satis page, you can actually just download the packages. You don't actually, if anybody gets access to that URL, they can download the package. You're going to want to firewall it. Again, it's not secure by default. You can also use SSH instead of HTTPS to host the actual Satis. So if you don't need that Satis web page, which I don't find terribly useful anyway, you can use SSH to pull the packages down instead of doing HTTPS. If you're going to use the web server, use HTTPS instead of HTTP. Unless you're on a private LAN, you don't have to worry about it. And one other little trick, and this is just being a little bit crazy, you can just generate it to a secret folder. Like put a hash in the folder where you're hosting it, right there. That big long hash there. It's not very long, but you get the idea. And that way, if anybody just gets your web host, they won't know that it's package server. And maybe come up with a better name than package server. Another little open source library that I would recommend for improving on Satis. This is basically a it's Satis on steroids. It has like a web interface to do all this configuration stuff. So if you're more comfortable with that kind of thing than versus using command line and updating that satis.json configuration file, this is a good idea. But you have to use a data. It has to have a database and a few other things. Just kind of wrap up. Again, thank everybody from the Composer and Satis team that have built on this. This has been great for PHP. Tons more documentation, way more than I would ever write on getcomposer.org. They have a full, basically, tutorial on how to install it, get it set up, use Composer, and download packages. One thing I'll mention, and this year at PHP Tech, again, last year I got to talk on this and give this presentation, so I was very thankful to them. Recommend going to this conference. It's a great conference. If you enjoyed listening to me today, I'm giving 2 talks there. One on virtual reality web apps, and the other one is on deconstructing domain-driven design, basically. So, as Samantha mentioned earlier, if you want to give me feedback, this is the URL for it. She said she's going to have it too. I'm going to post these slides whenever my hangover clears tomorrow. There. So if you want to find it, and that's it. And thank you. Questions about Satis at all? And hosting your own packages.
Would you mind a question about the composer.log file?
Yeah.
Perfect. So a lot of repos I've seen don't like they. Is your recommendation to not ignore that? And
So, yeah, go ahead.
Can you talk about the pros and cons?
Yeah. Okay, so open source projects that typically an open source project is going to want to be flexible with the other dependencies that it requires. So they're not going to have the composer log file. The dependencies that you're using, it's going to pretty much ignore anyway. So if it was that scraper library and it required the Symfony HTTP library, they're going to just say use version 2.8 or whatever, and any one of those versions is fine. Now, for your code in your composer JSON, I wouldn't personally trust that without using the composer log, because that way you can guarantee that that version that you're using on your dev machine is exactly the one that's going to be going on production.
Gotcha.
That answers.
Yeah, that does. Thank you.
Anybody else?
When you develop your internal packages, you always tag them. We tend to use like the master that develop our internal packages.
Yeah.
I understand it's not like the idea when you use like third-party packages, but what do you think?
Okay. Yeah. So great example. So I just went through this the last week or so, where we have like kind of a framework package that just has a few things, a few tiny little things that we use commonly everywhere. We had it on version 7. We're going to version 8. And what's nice is we still have existing applications that are using version 7. So it's tagged, and we know that those can be deployed. We can make little updates and little hotfixes to that and not have to worry about changing the framework piece, which may take a few hours to fix, but we can make this little change, get the hotfix out quickly if we need to. By tagging it, using the release and the versions now, I updated the other app to version 8. Now eventually we'll get time to go and bring the other one from 7 to 8. But it's a good advantage to basically keeping everything going. You don't have to keep every project that you have marching right along. Now we have we're supporting about 5 applications basically, and none of them are on the same version of anything. It's only getting that way as we get time to update. Using dev master can be dangerous because if you push something into it, the next time you run composer install or update, composer update, it's going to pull down that version. It's safe as long as you're using the composer log file. You'll be okay. It's going to pull that specific commit, not that tag version. So, yeah.
I mean, I think I might know the answer.
Yeah.
But
So it's a trick question.
I want to say it out loud. So how do you handle third-party packages where you're requiring a tagged version of it?
Yeah.
And their dependencies are requiring dev master.
Okay, you can actually get around that. You can alias libraries in the composer JSON. You can specify, I'm not really sure of the syntax, but you can basically, if they're using dev master, you can alias it and force it to be a specific version. Now, also your composer lock will guarantee that will always get installed in the same way. But I would submit a pull request, honestly. If it's an open source package, be like, why the fuck are you using dev master? Maybe nicer than that. But
Yeah, I mean, I was kind of thinking about that it was using the composer log file
yeah.
to manage it.
Yeah, if you run composer update, Wild Wild West.
Okay, thanks.
Any other questions? All right, thank you guys. Thank you, Spencer.
Thank you.
Either.